Hello everyone, welcome back to this session. In this session, we are discussing a difficult question from logarithm. If you can see, it's a pretty old mock CAT from 2011. Nevertheless, the topic of logarithm is very important. You see that every year they test you 1 or 2 questions from the topic of logarithm across every slot. So all the more important for us to discuss. By the end of this video, I'm also going to give you the textual solution that this institute has provided. So just stay tuned, right? Now, I'll also talk a little bit about the Trident workshop classes that I'm conducting under the banner of Trident, of course. We'll talk more about that towards the end of this. Let's see how we can solve this question under 2 minutes. The first thing that you need to realize is that w, x, y, and z are natural numbers, okay? And then statements are given such that log x to the base y is given as 3 upon 2, log w to the base z is given as 5 upon 4, y minus z is equals to 10. What is the value of x minus w? If you can see, the options are also far apart. So the first one 81, 170, 93 and so on, and 109. So these are actually far apart options. We can actually make use of these things. Okay. So the first thing that comes to my mind is that we'll use the property of change of base of logarithm. The property of logarithms are very important for you to remember. So what I can do over there is that I can pretty much write this thing as log x upon log y is equals to 3 upon 2. This thing is allowed so long you keep the base intact. Now for my, let's say benefit, I'm taking the base as 10. From this, the another thing that you keep in mind is that you can transpose the log base 10 to the RHS, or you can also use the anti-log property that basically cuts the logarithm across both sides, and you will be left with x upon y is equals to 10 raised to the power 3 upon 10 square. Now, because this is a recorded video, I'm not going to elaborate too much on this, but this thing is pretty much allowed. If you realize 10 cube upon 10 square can very well be written as 10, that's it. Now we'll do a similar situation for the other part, which is log w upon log z. So log of w upon log z, again the base is kept as 10. You have 5 upon 4. This thing can be again transposed as w upon z is equals to 10 raised to the power 5 upon 10 raised to the power 4. Again giving you 10. Now what is the benefit of doing this thing? The benefit of doing this thing is that I'm taking it to the whiteboard now. The benefit of doing this thing is that now I have some values for x and y. Okay, if you remember the question, they have given you y minus z is equals to 9. Obviously, I have some sort of an expression over there in w, z and x and y. So if I transpose y to the RHS, you will see I can write y as x upon 10. And z can be written as, if I transpose z to the RHS, I can write this as w upon 10. That is equals to 9. Now if you take 10 common, you will get 10x. Or if I just take 1 upon 10 common, I can write it like this. Okay, that is equals to 9. Now if I substitute this 10 to the RHS, this will become x minus w is equals to 90. Now please remember, the closer option to this 90 is going to be my answer. Let's see. The closer option to this one is given in option number C. Now I will show you the explanation. Now guys, if you're convinced with this method, I will now show you the textual solution that the institute has provided. Now, please pay attention to the yellow highlighted portion. The yellow highlighted portion is the answer. What they have done is basically, they have done some algebraic operation to arrive at the answer, which is 93 only, which is option number C. Now, if you are hell-bent on understanding what they are, let's say, what they have done over there, so let me do one thing. Let me show you how you can algebraically also you can solve this thing. Okay. So I'm again going to take you to the, let's say I'm taking you to the black screen, just so that you understand this thing. If you remember, you have been given that log of x base y is given as 3 upon 2. Log of w base z is given as 5 upon 4. Now, what I can do from there is that I can actually change the base, and for the reciprocal part, I can do this thing. You can do this thing, log x upon log y is equals to 3 by 2. You can do then log of y upon log of x, that is equals to 2 by 3. And now you can take the same, because the bases are same, I can do this thing, log y to the base x is equals to 2 by 3. Okay, now log y base x. Please remember, I'm taking anti-logarithm to the both side. This eventually gives me y is equals to x raised to the power 2 by 3. Or you can also remember this thing, or let's say also appreciate this thing as shifting the logarithm to the transposing the logarithm to the RHS. Okay, now I'll take you back to the screen. This is exactly what they have done for, I have explained one of the variables. Let's do the same for the other variable, and let's see what else we can do. Okay, now just now I have mentioned that log y base x is equals to 2 by 3 can very well be written as y is equals to x 2 by 3. Similarly, the next expression would be log of reversal z base w is equals to 5 upon 4. That can be written as z is equals to w raised to the power 4 by 5. Okay, this is 4 by 5, right? Because log w to the base z was 5 by 4, so the same thing will be reciprocal, right? So we have got this thing. Beyond that, you have realized that we have got the value of y and z in x and w. Now we need to use the same third statement. Y minus z is given as 9. Okay, this is given in the statement, and just now we calculated x to be 2 by 3 and z to be w raised to the power 4 by 5, that is equals to 9. Now if you are a little smart, you can do this thing, x raised to 1 by 3 whole square minus w raised to the power 2 by 5 whole square, that is equals to 9. And then obviously this is a square minus b square, so you can do x1 by 3 plus w2 by 5 and x1 upon 3 minus w2 by 5, that is equals to 9. Now 9 is a composite number. It can be broken down into its prime constituents, 1 into 9, 3 into 3, and because it is values, I can also take 9 and 1. This is also allowed. Now if you realize what I have basically done, I have assumed the values for this expression and this expression. Because predominantly the question asks me about x minus w, I will only be focusing on this part. So there are 3 possible cases, 9, 3 and 1. You'll have to substitute for each of them to get to an answer. I am leaving that business to you. Okay, you can do that much. And little bit on the Trident workshops. Conducting Trident workshops for DILR and QA. This is going to be weekend workshops. The entry fee will be 9,999. That's it. Okay, now any further information if you want to get access to, you can comment in the video. You can also get in touch with the links that I have provided in the description. Thank you.